Hello, calculus students. This is Mr. McAllen speaking, and today in class, again, this is a recap of what we did in class. And what we did was we talked about continuity at a point, the three types of discontinuities. We talked about what a continuous function is, as far as an easy way out to discuss continuity. And we didn't discuss these last two because the lesson wasn't designed for that. So in starting out with a lesson, and the way we developed it was I asked the students to go up to the board and draw a function that has a single discontinuity on it and to try to label it. So I received some graphs from the students that looked like this, and the student labeled this to be a jump. I got another graph that looked like this, and we call that an infinite discontinuity. And then I got some that looked like just, kind of that it was a graph of a line with a hole kind of right in the middle of it, and we call that, even with the function value above it, we call that a hole discontinuity. So so we had the students actually, they knew quite a bit about what a discontinuity is, but today's lesson was really to focus on how do we actually describe a continuity or a discontinuity using limits and using the definition for continuity. So, we set up the lesson where we said, imagine that, we know that there's a jump discontinuity here at 1. We know that there's a hole discontinuity here at 2. And we got into the definition of what it means to be continuous from both sides, a two-sided continuity, or if you have a function that just is defined from from the point A moving to the right, then this would be continuous from the right that we would define, and we have continuity from the left. The lesson really focused around the definition for continuity that's right here in the center of the page. And so we defined it, and what I had the students do, I'm just going to kind of go to the end of the lesson and construct what we did in class. And so the first graph we looked at, we it was a line, and there was a hole in the graph at, let's say, 2. So we had the students ask in their notes, and we said, "Is this a discontinuity?" And they said, "Yeah, sure. It's a hole discontinuity, or a removable discontinuity." Let me just write this better. But then we want to use the rules for continuous functions, or defining a function to be continuous, to help define or show that it was not continuous. So the rules are the three of the following things you've got to show. First thing you have to show is at the value. So if you're trying to prove f of x is continuous at x equals a, and a is like some value of x, so it could be, in this case, it's 2, you would have to show the following. You have to show that f of 2 exists, or f of a exists. That's the first part. The second part is the limit as x goes to a, the limit of the function has to exist. And the third part is that the function value, the limit as x goes to a of the function has got to equal what the function value is at a. So in this case, the very first part, when they say let's talk about continuity at x equals 2, you would say it's not continuous at x equals 2 because, part 1, f of 2 does not exist. So right here, the students know a justification for this function not being continuous. So for a hole discontinuity, flat out, the function doesn't exist. Now, the second scenario we painted for the kids was, what if there's a hole in the function, but above it, it does exist? So, at 2, we have there's a hole, and then you have a value at, this is 1, 2, and 3. So if we would say for this, it's clearly not continuous at x equals 2, but now for a different reason. Because the first reason from before, so for part 1, f of 2 does exist, and such that f of 2 is actually equal to the value 3. In the second part, does a limit exist? Yeah, the limit as x goes to 2 of the function does exist because from both sides, the limit is heading to the value of 1. But this is where continuity kicks in as far as saying that it does not have continuity at this point. Now everyone knows it's not continuous because you've got a hole in the function and it's got a value above it. But in terms of describing what's going on, you would say the third part, you would say, well, the function value or the limit value as x goes to 2 of the function, although it equals 1, that's not equal to the function value at 2, which equals 3. So because the first part of the limit continuity test and the second part don't equal the same value, you've got a discontinuity. Then we moved ahead to another type of discontinuity to describe using these rules. And that was, in class, we did a jump. So we had a function that clearly had a jump at, let's say, x equals 1. So for the first part, we would, of continuity, we would say, so the students would say on a multiple choice test, they'd say f of x is not continuous at x equals 1 because they would say they see a jump. But in terms of justifying a jump in AP Calc on the open-ended, you would have to say that, f of 1, does f of 1 exist? And you would say, yeah, f of 1 exists. It's got the value of 3. And the second part is, does a limit as x goes to 1 of f of x exist? And right here you would kick out of the continuity business because you would say that the limit does not exist because the limit as x goes to 1 from the right is not equal to the limit as x goes to 1 from the left. So basically, part 2 doesn't exist. And this is why any jump in a function results in a discontinuity, is because the limit doesn't exist. Last continuity we went over in class was what happens if you have an asymptote. Let's say at x equals 3, I have a function that looks like this. So this function would be represented by 1 over, let's say, x minus 3 quantity squared. So in terms of discussing continuity here, clearly discontinuous at x equals 3 because now the students would say it's an infinite discontinuity. So they would infinite discontinuity. As I work on my spelling. But for AP Calc, you would have to, for the justification on open-ended, you would have to state the limit rules. You would have to say, for the first part, does f of 3 exist? And right here you would stop because you'd say, well, f of 3, no, f of 3 is not in the domain of the function. So therefore, you can't even check for continuity because there's not even function value there. So this is the main point. These were the main points of today's lesson. We did talk about some other things in the lesson. We talked about how you analyze continuity of a piecewise function using those rules. And in the homework tonight, we're going to have the students, they're going to go over problems where they've got to discuss these types of things. So hopefully this video has helped recap the idea of checking for continuity using traditional explanations instead of just describing what the continuity is. And I look forward to hearing your comments and talking to you guys in class about this tomorrow. Take care.